Welcome to the routing room, and today we're going to level up our knowledge on the OSI model, the Open Systems Interconnection model. Now, this video is not going to be a deep dive. It's going to be a pretty quick overview of just what the OSI model is. And later on, we'll have a video where we actually kind of dive a little bit deeper and go into some more in-depth things with the OSI model. So what is the OSI model? It's essentially a framework that lets us visualize how networks communicate. It does that by dividing a network into 7 logical layers, and it was created to help standardize communication across different vendors. Now, primarily, we're going to use the OSI model to try and help us learn and troubleshoot issues. So now, what are those 7 layers of the OSI model? First one is our physical layer. And what that layer is concerned with is the actual physical transmission of data from one point to the next. We're talking about the actual bits, the binary, the ones and zeros that are transmitted across whatever the transmission medium is. That can be copper, so that's like our Cat5, our Cat6 cables. It can be fiber, single mode or multi-mode, Wi-Fi, Wi-Fi 5, Wi-Fi 6, Wi-Fi 7, or it can be cellular in the form of 4G, 5G, whatever the cellular signal is. At layer 2, we have our data link layer. That's where our MAC addresses live, where all of our switching happens, and as well as our virtual local area networks, or VLANs. That all happens at layer 2. And then we have our Ethernet protocol and our ARP protocol at layer 2. Layer 3 is our network layer. That's where all of our logical addressing happens. So like our IP addresses, IPv4, IPv6, as well as routing with protocols like EIGRP, OSPF, and as well as ICMP, which is our general troubleshooting protocol, which lets us do ping, trace route, things like that. At layer 4, we have our transport layer, which handles our end-to-end communications, as well as our ports that we're all familiar with, the port 20, port 80, port 443, 22, 23, 53. All those ports live at layer 4. As well as reliability, that's all handled at layer 4, or lack thereof reliability, depending on what layer 4 protocol that we're trying to use. So we have TCP, which is Transmission Control Protocol, or UDP, which is User Datagram Protocol. TCP is going to be the more connection-oriented protocol that gives us our reliability and error control, versus UDP, which gives us a best effort to reach the destination. Layer 5 is our session layer, which, you can guess it, does our session setup, as well as session management and session teardowns as well. So all of that session setup stuff that happens whenever you make a connection to a server, all that's handled at layer 5 of the OSI model. Layer 6, we have our presentation layer. Now, a big test question here, which you'll see on exams, you'll have a question, or you'll most likely have a question that asks you, which layer of the OSI model performs encryption? That is layer 6 of the OSI model. And our encryption standards like TLS, SSL, those live at layer 6 of the OSI model. TLS being transport layer security, and SSL being our secure sockets layer. It is worth noting that SSL is a deprecated protocol, so try not to use it. TLS is the newer version, and it is not yet deprecated. Layer 7, which is the closest to the user, is the application layer. Therefore, it is our user-facing network services. HTTP, HTTPS, DNS, SSH, Telnet, all that stuff all lives at layer 7. Now, something to note here is while the applications themselves live at layer 7, the ports that those applications use live at layer 4. So HTTP, the application, uses port 80, and that port itself lives at layer 4. So how do we troubleshoot with the OSI model? Well, it helps us understand where a problem is happening in the OSI model itself. Answers the question, at what layer is this problem happening? And we always want to start at layer 1 and move up. And the question at layer 1 is the device plugged in? Is it receiving power? Is the cable plugged in? Those are all our basic layer 1 questions, which is where you should start. There are countless number of hours spent trying to diagnose an issue where we don't start at layer 1. We're trying to troubleshoot a routing issue or a port security issue or a port block or an application issue, when in fact the device was never plugged in the first place. So always check and make sure the device is in fact plugged in before you start troubleshooting those higher layers. Each layer is going to answer a different question. If the device is plugged in, you can verify those cables are actually seated correctly. Are there blinky blinkies? And what I mean by that is, if you look at the image down in the bottom right corner there, you see the front of a switch. Those lights you also will see on the back of your desktops as well, most likely. And if those lights are flashing, it generally is going to mean you have some sort of connectivity. So when we ask the question, are there blinky blinkies, we literally mean, are the lights flashing? Are the lights doing the blinky blinky? Let us know that we have connectivity. Because if we can verify the cables are seated correctly, but we're not getting blinky blinkies from the switch or from the port that we're plugged into, then maybe we have a bad cable. Maybe we need to replace that cable and make sure that it is a known good one. Because with certain cables, or just cables in general, they can break or have some sort of disconnect in the middle somewhere, or they're broken somewhere. They're not in the RJ45 jack correctly. So just because we can verify the cable is seated doesn't necessarily mean that there is a good connection there. So always ask, are there blinky blinkies? That is our layer 1 question. Now we can move up to layer 2. And now we're going to ask the question, okay, well, is this device in the correct VLAN? And if we're talking about a trunked network, is that VLAN actually implemented on the trunk interface that's going out? Is it on the other side? Well, those are kind of our layer 2 questions. And when we get to layer 3, then we get some more complex routing issues. Is the route that we're trying to get to, is it in the routing table? Is it being leaked into OSPF properly? Is it in our EIGRP table? Whatever routing protocol we're using, is that route actually in there? So, with all that being said, that's all for this video. I will see you in the next one.